Dear students, welcome to Siva Reddy Logics. RRB ALP నోటిఫికేషన్ రీసెంట్గా రిలీజ్ అయింది. మీ లక్ష్యము RRB ALP జాబా? మీకోసం శివ రెడ్డి లాజిక్స్ పర్ఫెక్ట్ కోర్స్ని మీ ముందుకు తీసుకురాబోతుంది. స్టూడెంట్స్ మీరు ఒకటే గమనించాలి, మనకు RRB సిలబస్లో మ్యాథ్స్ రీజనింగ్ తర్వాత ఎక్కువ వెయిటేజ్ ఉన్నటువంటి సిలబస్ జనరల్ అవేర్నెస్ కంటే కూడా జనరల్ సైన్స్ అనేది చాలా ఇంపార్టెంట్. ఈ జనరల్ సైన్స్లో ఫిజిక్స్, బయాలజీ, కెమిస్ట్రీ. దీంట్లో ఫిజిక్స్ పాయింట్ ఆఫ్ వ్యూలోనే శివ రెడ్డి లాజిక్స్ ఏం చేసింది, ప్రీవియస్ ఇయర్ పేపర్స్ని పర్ఫెక్ట్గా అనాలిసిస్ చేసి ఏ ఏరియాస్ నుంచి క్వశ్చన్స్ వస్తున్నాయి వాటిని కంప్లీట్గా అనాలిసిస్ చేసిన తర్వాత అప్డేటెడ్ NCERT టెక్స్ట్ బుక్స్తో మనము పర్ఫెక్ట్ కోర్స్ని డిజైన్ చేయడం జరిగింది. ఒక ఫిజిక్స్లోనే ఆల్మోస్ట్ 40 to 45 అవర్స్ వీడియో కంటెంట్ మీకు ఇస్తున్నాం. అంటే జనరల్గా ఫిజిక్స్ అంటే ఒక 20 అవర్స్ 10 అవర్స్ చెప్పిచ్చేస్తారు. మహా అయితే మీకు ఆఫ్లైన్లో మీరు ఎక్కడికైనా వెళ్ళినా సరే ఒక 10 అవర్స్ 20 అవర్స్ చెప్పిచ్చేస్తారు, లేదా 30 అవర్స్ చెప్పిచ్చేస్తారు. కానీ ఆన్లైన్లో 40 to 45 అవర్స్ కంటెంట్ అంటే అది మీకు ఆఫ్లైన్లో ఆల్మోస్ట్ 80 to 90 అవర్స్ కంటెంట్తో సమానం. మీరు అది గమనించాలి. వెరీ బేసిక్ లెవెల్ నుంచి అడ్వాన్స్ లెవెల్ వరకు కూడా మనము ఈ ఫిజిక్స్ కోర్స్ని రికార్డ్ చేయడం జరిగింది. ఓన్లీ కంటెంట్ ఇవ్వడం కాదు, కేవలం ఫిజిక్స్ సబ్జెక్ట్ మీదే 100 టాపిక్ టెస్ట్లు ఇవ్వడం జరుగుతుంది. 100 టాపిక్ టెస్ట్ అంటే ప్రతి టెస్ట్లో ఒక 20 క్వశ్చన్స్ ఉంటాయి. 100 into 20 అంటే ఒక ఫిజిక్స్లోనే 2000 మల్టిపుల్ చాయిస్ క్వశ్చన్స్తో టెస్ట్ సిరీస్ కూడా ఇవ్వడం జరుగుతుంది ఓన్లీ ఫిజిక్స్ మీదే. అంటే ఓన్లీ ఫిజిక్స్ మీదే 40 to 45 అవర్స్ కంటెంట్ ఇస్తూ, అప్డేటెడ్ కంటెంట్ ఇస్తూ, కేవలం ఫిజిక్స్ మీదే 2000 క్వశ్చన్స్తో టెస్ట్ సిరీస్ కూడా ఇస్తున్నాం కేవలం ఫిజిక్స్ మీదే. ఇంత కంటెంట్ మీరు పర్ఫెక్ట్గా ఫాలో అయినట్లయితే RRB ALP జాబ్ మీ సొంతం అవుతుంది. క్వాంటిటీ విషయంలో కావచ్చు, క్వాలిటీ విషయంలో కావచ్చు, అప్డేటెడ్ కంటెంట్ విషయంలో కావచ్చు, NCERT బేస్డ్ కంటెంట్ విషయంలో కావచ్చు, ప్రీవియస్ ఇయర్ పేపర్స్ని పర్ఫెక్ట్గా ఎనాలిసిస్ చేసి కోర్సును డిజైన్ చేయడంలో కావచ్చు, టెస్ట్ సిరీస్ విషయంలో కావచ్చు, మీరు ఏ పారామీటర్ని కంపేర్ చేసుకున్నా, వేరే ఏ ఆర్గనైజేషన్స్తో కంపేర్ చేసుకున్నా శివ రెడ్డి లాజిక్స్లో ఉన్నటువంటి కంటెంట్ ద బెస్ట్ కంటెంట్ ఉంటుంది. మీరు కావాలంటే కంపేర్ చేసుకోండి. ఎందుకంటే ఇది లైఫ్. 6 సంవత్సరాల తర్వాత రాక మనకు అవకాశం వచ్చింది. ఈ అవకాశాన్ని మీరు పర్ఫెక్ట్గా యూటిలైజ్ చేసుకోవాలి. ఒక బెస్ట్ కోర్స్ని మీరు ఫస్ట్ ఎంపిక చేసుకోవాలి. ఒక బెస్ట్ ఆర్గనైజేషన్ మీరు ఫస్ట్ ఎంపిక చేసుకోవాలి. దాని తర్వాత మీ ప్రిపరేషన్ మీరు కొనసాగించాలి. ఎందుకంటే ఇక్కడ మీరు ప్రిపేర్ అయ్యేది ఏంటో క్వాలిటీ కంటెంట్ అయితే, మీరు ప్రిపేర్ అయ్యేదో అప్డేటెడ్ కంటెంట్ అయితే మీరు ఎలానో ప్రిపేర్ అవుతారు, ఎలానో కష్టపడుతున్నారు. ఆ కష్టపడేది ఏందో, ఆ ప్రిపేర్ అయ్యేదేదో క్వాలిటీ కంటెంట్ ప్రిపేర్ అవుతే, అప్డేటెడ్ కంటెంట్ ప్రిపేర్ అవుతే, ద మోస్ట్ ఎక్స్పెక్టెడ్ క్వశ్చన్స్ మీరు ప్రిపేర్ అయితే మీరు సక్సెస్ అవుతారు. RRB ALP జాబ్ మీ లక్ష్యమైతే శివ రెడ్డి లాజిక్స్ అందిస్తున్నటువంటి ఈ అద్భుత అవకాశాన్ని మీరు సద్వినియోగం చేసుకోండి. ఆల్ ది బెస్ట్ ఫర్ ఎవ్రీవన్.
Magnetism, it is also form of an energy. We know that. What is magnet? Magnet, it is a material. It has the two poles and also it can attract the metal materials. And one more thing, it has the some forces. These forces are the invisible forces. See, magnetism, an invisible force that pushes or pulls the magnetic materials, and it has the two poles. They are North Pole and South Pole. In the chapter magnetism, top chapter, will discuss the following concepts. They are, initially we discuss about the introduction, later classification of materials, properties of magnetic materials. So many properties are there, like pole strength, and also magnetic length, geomagnetic length, magnetic moment, axial line, equatorial line, and also magnetic flux, magnetic density, flux density, and other definitions also there. And also we'll discuss the Coulomb's inverse square law and few important concepts. Next, types of magnetic field, types of magnetic field, later geomagnetism. These, and also later we'll discuss the applications of magnetic materials also. We'll discuss the applications of magnetic materials or applications of magnets. Here, applications of magnets also we'll discuss. Applications of magnets. Right, anyhow, first of all, going to discuss about the introduction part. See, we know every material, introduction part in this, every material has some independent, unique nature, we know very well. So this independent nature or unique nature, what is that unique nature? That means the material which has the attraction nature or push or pull, the pulling nature, that material is said to be what we call magnet. This magnet word originated from the place of Magnesia, which is in the Turkey country, we know. So on Magnesia, it is available, or it was initially identified at that place, Magnesia place, so it is called as magnet. And another word is, we know, a Shepherd. A Shepherd identified the magnetic nature, means attraction nature of the material. A stone which is attract the metals, especially is shoe nails. That is why the material has some attraction nature. It was initially identified and explained the nature of that stone by magnet. So Magnus, Saint Magnus Shepherd, so it is also known as magnet. So on this place or person, it is called as magnet. Here has the natural nature, the material which has the naturally attracted nature. That kind of materials are called as lodestones. Lodestone. Naturally available magnets are called as lodestones. Naturally available magnets are called as lodestones. One of the example for lodestone, the earth. Earth is the one of the lodestone. The earth. Earth is the lodestone. Up to now, the strongest magnetic material up to known one is neodymium. Neodymium, it is the strongest magnet. Strongest magnet. So like this, to studying about this concept of magnet, the importance of systematic studying about the magnet was initially introduced by William Gilbert. An importance of systematic study given by William Gilbert, scientist. William Gilbert, he was suggested or explained the systematic study about the magnetism or magnetic nature. Later, some of the other scientists also influenced by the William Gilbert, they try to develop this concept, magnetism concept. They Who tried to develop this concept? Yes, we know Weber, Ewing, Ewing, Ampere, Ampere, Curie, Curie, Faraday, Faraday, etc. Yes, Weber, Ewing, Faraday, Ampere, Curie scientists also try to explain the systematic study about the magnetism. And we'll discuss some more words about the magnetic nature. So here, according to magnetic nature, we can classify the materials two types. Materials are mainly classified or segregated into two types according to magnetic nature. What are they? One is magnetic materials and another one is non-magnetic materials. Magnetic materials, materials classified into two types. They are, one is magnetic materials, another one is non-magnetic materials. Non-magnetic materials. Non-magnetic materials. Magnetic materials are having the magnetic nature, either attraction nature or repulsion nature. We'll discuss. So it has the some special characteristics comparatively non-magnetic materials. What is the reason why these are having that special characteristics? Because of the structure or the configuration of the electrons which are present in the, what is that, magnetic materials. The systematic configuration of the electrons in these materials. So what is the reason materials are having or exhibits the magnetic nature? Electricity. Due to the electricity or electric energy, due to the electric energy, what happens? Materials are having the magnetic nature. What is the reason some materials exhibits magnetic nature? Because of, what is the reason? Electric energy or electric force. Non-magnetic materials, these do not having the attraction nature or repulsion nature. Example, human body. Human body, rubber, rubber, plastic, plastic, wood, wood, paper, paper, cloth, cloth, and cotton, etc. These are the some examples for non-magnetic materials. Here, one important word is there. What is that? Let us see. Human body. Actually, human body is the example for non-magnetic material. But in our body, two organs, especially two organs, are influenced by the, are affected by the magnets. What are they? One is, what are the two parts? What are the two organs? Yes, one is heart, and another one is brain. Heart and brain are the two organs. These are influenced by the magnets. These are the important words. Heart and another one is brain. Now, going to discuss about the magnetic materials. Magnetic materials are mainly classified into three types. Classification of magnetic materials. Magnetic materials are mainly classified into how many types? Three types. Three types of materials are there. What are they? We know ferromagnetic materials, another one is paramagnetic materials, another one is diamagnetic materials. Important one. Magnetic materials are mainly classified into three types. One is ferro, another one is para, another one is diamagnetic material. What are the examples for ferromagnetic materials? Example for ferromagnetic materials, especially metals exhibit the ferromagnetic nature. Right now, see, paramagnetic material, these nature exhibited by liquid, solids, and also gases. Diamagnetic materials are also example for diamagnetic materials, solid, liquid, and gaseous materials. What are they? See, example for ferromagnetic materials. For ferromagnetic materials, iron, iron, nickel, cobalt, steel, alnico, gadolinium, dysprosium. These are the examples for ferromagnetic ferromagnetic materials. Means these are strongly attracted by the magnets. These materials are strongly attracted by the magnets. What are the examples of ferromagnetic materials? Solid materials. Examples of solids: iron, nickel, cobalt, steel, alnico, gadolinium, dysprosium. These are the examples. See, one more important word: steel composition. What is the composition of steel? Iron plus carbon. This is the previous competitive examination question. Previous year question. Composition of steel is iron plus carbon. And also, what is the composition of alnico? See, it is very easy to identify, very simple. See, al means aluminum, ni means nickel, co means cobalt. So aluminum plus nickel plus cobalt, and also add the some amount of iron. So iron, aluminum, nickel, and cobalt are the examples for, or the composition in alnico metal. Alnico alloy. What is its name? Alloy. What is alloy? Alloy, it is the mixture of metals. Mixture of metals is called as what we call alloy. Alloy, alloy is the mixture of metals. Alnico is the example of alloy. Steel also example for alloy. Its composition is iron plus carbon. Its composition, al means aluminum, ni plus nickel, co means cobalt. Extra we add the iron. That is important one. This is also. See, one more thing. These are strongly attracted by the magnets. Next, due to this strongly attraction nature, these magnetic materials are used to prepare the permanent magnets. Important one. These are used to prepare the permanent magnets. So permanent magnets are made up of permanent magnets are made up of, important one, either steel or alnico. Already we know the composition of steel and alnico. Steel composition iron plus carbon, alnico composition is iron, aluminum, nickel, and cobalt. Right? Permanent magnets are made up of steel or alnico. Right now, temporary magnets are made up of, how to prepare the temporary magnets? So temporary magnets are made up of, see, soft iron or soft iron is used to prepare the temporary magnets. And also one more thing, another important one, all these most important one, Previous year questions, all are these. Right. Another one. Electromagnets are made up of. Electromagnets are made up of. Electromagnets are also made up of soft iron or iron. One more important word in transformer. In transformer, core material also in transformer core material also made up of soft iron or iron. So iron is used in temporary magnets, electromagnets, and also transformers. In transformers as a core material. Important one, please concentrate on this. These are the ferromagnetic materials, their examples. Let us see some more words. Next one, these are strongly attracted by the magnet. Now only we discussed about this one. Okay, next one. These are feebly attracted, partially attracted, weak attraction nature. But diamagnetic materials are feebly repelled by the magnets. These are having the repulsion nature. These are partially attraction nature. These are strongly attraction nature. What are the examples for paramagnetic materials? Examples for paramagnetic materials. Paramagnetic materials. Paramagnetic materials. What are the examples for paramagnetic materials? Right. Examples for paramagnetic materials. Yes, we know aluminum, magnesium, manganese, platinum, oxygen, and chromium. Aluminum, magnesium, manganese, platinum, oxygen, and chromium are the examples for paramagnetic materials. These are partially or these are weakly attracted by the or weak attraction nature. These are partially attracted by the magnets. Next one is diamagnetic materials. Examples for diamagnetic materials. Diamagnetic materials. Example for diamagnetic materials: gold, gold, silver, copper, copper, brass, brass, hydrogen, water, mercury, mercury, antimony, bismuth, etc. Gold, silver, copper, brass, hydrogen, water, mercury, antimony, and bismuth. These are the examples for diamagnetic materials. Please be focused on this area. Examples for ferromagnetic material, or which of the following doesn't a magnetic material, what we call doesn't a ferromagnetic material? Which of the following are the magnetic paramagnetic materials? Like this, examiners asking the questions. Please be focused on this area. One more thing here, ferromagnetic materials, these are strongly attracted by the magnets, but these are partially attracted by the magnets. Okay, here Curie temperature. Curie temperature. What is Curie temperature? How to define this? Curie temperature is defined as the required temperature to convert the ferromagnetic material into paramagnetic material. Required temperature to convert the ferromagnetic material to paramagnetic material. right now. Most important one, required temperature to convert the ferromagnet into para means strongly attracted material is converted into partially attracted material. So these materials are partially attracted by the magnets. So at what temperature or the required temperature to convert the ferromagnet into para is called as Curie temperature. Iron is the ferromagnet, we know. Iron is the ferromagnetic material. It will convert into paramagnetic material at 1043 Kelvin. At 1043 Kelvin, it converts into paramagnetic material. Direct question this is, at 1043 Kelvin, iron behaves like as paramagnetic material. At room temperature, iron behaves like as ferromagnetic material. What is the Curie temperature of iron? Curie temperature of iron is 1043 Kelvin or 770 degree Celsius. Like that, examiners asking the question. Right, these are the examples and one important concept here. And see some more words here. Movement from low high field region, here movement is low to high, here high to low. So the movement of the particles is like this. It is not important in competitive examination point of view. So here permeability is, this is important. Permeability is very high for ferromagnetic materials. Here little greater than unity means value is more than 1. Here it is permeability is less than 1 for what is that? Diamagnetic materials. So here permittibility, how much force enter into that material, that value is less than 1, here greater than 1, here more value. Susceptibility, it is denoted with xi, here value is very high and positive, little greater but positive, less and what we say negative. Susceptibility values, see, very simple. It has the less values, it has the moderate values, it has the high values. Just that is only have to remember, either permeability or susceptibility, whatever it is. And also remind that examples and basic concept. Strongly attracted, partially attracted, repelled, examples, and these two. Here also very simple. For ferro, all or more. For paramagnetic material, permeability and susceptibility both are greater than 1 unit and positive. It is less than 1 unit, and also less than 1 is nothing but negative. Like that, identify the options for the given question. Now, going to discuss about the magnet. What is magnet? How it is? What are the properties of magnets? Properties of magnets. Properties of magnets are magnetic materials. Here, properties of magnets. Yes. See, magnet, every magnet, whatever it is, every magnet has the, every magnet has the, what we call, yes, every magnet has the two poles. They are, one is north pole and another one is south pole. So every magnet has two poles. They are north and south pole. That is why, see, every magnet consists the how many poles? Two poles. That is the basic information. Every magnet has two poles. Every magnet has how many poles? Two poles. Yes. Is it possible to coexist the single pole? Any single pole magnet is there? Its existence is possible? Never. So remind this, single pole magnet does not coexist in the nature. Single pole magnet does not coexist in the nature. It is impossible. Single pole magnet does not coexist. Right. So if it is the magnet, it must consist the two poles. They are, one is north pole and another one is south pole. Here, ability of attraction, ability of repulsion, that means magnetic nature presents only at the poles. Let us see, it is the magnet, it has the two poles. They are, one is north pole and another one is south pole. Every magnet has, already now only we discussed, that is every magnet has two poles. Here, magnetic nature also usually exhibit or presents only at the poles. Magnetic nature presents only at the poles of the magnet. Poles of the magnet only. There is no magnetic nature at the midpoint of the magnet. Magnetic nature is zero at the midpoint of the magnet. Magnetic nature is zero means, what is the meaning of zero? Zero means there is no attraction nature, there is no repulsion nature. Why? Total, it is completely one material. In this one, at one point it has the attraction nature and repulsion nature, but why at this position, why, what is the reason at this position value is zero? Because of, at the poles, either north pole or south pole, particles arrangement of particles is, structure of our particles is symmetrical structure. Particles are aligned in symmetrical, particles are aligned in symmetrical structure. Symmetrical structure, that is why it exhibits the, it, these poles exhibit the magnetic nature. But at midpoint, particles are aligned in asymmetrical structure. Particles aligned in asymmetrical structure, that is why asymmetrical structure. That is why what happens here, see, due to the asymmetrical structure at the midpoint, there is no attraction, there is no repulsion. Due to the symmetrical structure, north and south poles exhibit the magnetic nature. See, here particles alignment is helpful to exhibit the magnetic nature. What is the reason behind the magnetic nature? Presence of electric nature. These particles are having the electric nature, that is why it exhibits the magnetic nature, right? See, it is the magnet, we know. Every magnet has the two poles. They are north pole and also south pole. At midpoint, this is the midpoint. Let us suppose, if we drill a hole, means here, if we drilling a hole at the midpoint of the magnet, what happens? Its magnetic nature. If we drill a hole at the midpoint of the magnet, what happens? Its magnetic nature. At this point, its magnetic nature is zero. Magnetic nature at the midpoint of the magnet is zero. Zero. So that is why, even though we drill the hole at the magnetic, at the midpoint of the magnet, what happens? Magnetic nature zero. Why? Because before drilling the hole, before drilling the hole at the midpoint, before drilling a hole at the midpoint, what is the magnetic nature of the magnetic nature at this point? There is no magnetic nature. Even though drilling a hole at the midpoint, no change its magnetic nature. Like that, you have to remember, even though drilling the hole at the midpoint of the magnet, no change its magnetic nature. It remains the same. And note, one similar point is there, right? Important one, previous examination question. See, it is a one disc. Disc has a hole. Disc has a metallic disc has a hole. Now we supply the some amount of heat energy to the hole, to the disc. Supply the some amount of heat energy to the disc. What happens is what happens? The size of the hole. A metallic disc has a hole. If it is heating, what happens? The size of the hole. That is the previous examination question. Right? See, if we heating the disc, what happens? Its size will be increases. Size of the size of the size of the hole, size of the hole increases. Size of the hole will be increases. Hole increases. Size of the hole will be increases. Important one this is. Right, next one. Some more words. It is the magnet. It is north pole. This is south pole. It is the midpoint. Now see, magnetic forces are usually acting from north to south. Direction of the magnetic lines of forces in outwards is, what is the direction of the magnetic lines of forces in outwards? From north to south, but inwards it is from south to north. Remind this. Inside south to north, outside north to south. So that is why just you have to remember, it is like this. North is away, but south is inwards. South is inwards. Like this you have to identify this one. Okay, next one. Few important words in this. Pole strength. What is pole strength? It is a magnet. Yes, every magnet has two poles. They are north and south pole. Here, north pole of the magnet north pole, it has the some ability of attraction. Or if we bring the material near to the north pole, what happens? It is repelled by this one. So the ability of either attraction or repulsion of the pole of a magnet is called as pole strength. Similarly, here also same. The ability of attraction of the south pole or the ability of repulsion of the south pole with the neighborhood materials, that ability of either attraction or repulsion of the pole of a magnet is said to be what we call pole strength. Pole strength, it is expressed in ampere meters. What is the system of international unit to express the pole strength? Pole strength unit is ampere meter. Very simple. See, you can easily identify it. Strength means ability of attraction or repulsion. Which has that ability of attraction or repulsion? Pole. What is that? Magnet. So magnet has the two poles. These two poles are having the either attraction or repulsion nature. That ability of attraction or repulsion of the pole is said to be pole strength. Its SI unit is ampere meter. Important unit. This is important unit. Previous year question. Next one, magnetic length. What is magnetic length? It is a magnet. We know every magnet has the two poles. They are north pole and another one is south pole. This is the midpoint. Midpoint is denoted with O. The ability of attraction and repulsion presents only at the poles. How many poles are there? Two poles. What are they? North and south. Right. From midpoint to north pole distance is L. From midpoint to south pole distance also L. Distance in between north pole to south pole is 2L. 2L is the length in between the north pole and south pole. Only at these two poles magnetic nature exhibit. Magnetic nature exhibits only at the pole of the magnet. How many poles are there? Two poles. So distance between the length in between these two poles is said to be magnetic length. Magnetic length is denoted or represented by 2L. So it is considered only from pole to pole, not edge to edge. These are the poles. So it is called magnetic length. Next one, geometrical length. How to define the geometrical length? Geometrical length, it is defined as, see, this is the north pole, N. This is the south pole, S. It is the midpoint. Now, geometrical length means, as per geometry, as per the material, length is from where this edge to this edge. Length in between the two edges of the magnet is said to be geometrical length. Length in between the two edges of the magnet is called as geometrical length. Geometrical length, it is denoted by capital L. What is the relation between geometrical length and magnetic length? What is magnetic length? Magnetic length is, it is the length between the two poles. What is geometrical length? Length in between the two edges of the magnet, right? How to define this one? How to say the relation in between these two? Relation in between magnetic length and geometrical length. Relation in between magnetic length and geometrical length. Relation between magnetic length and geometrical length. Magnetic length 2L is equal to 5 by 6 into geometrical length. Magnetic length 2L is equal to 5 by 6 into, what is that? Geometrical length. Most important. This is the previous year question also. Previous year question. Magnetic length 2L is equal to 5 by 6 into geometrical length, or magnetic length is less than geometrical length. Magnetic length is always less than the geometrical length, because of, see, distance from north to south is 2L. This length is always less than the length in between the two edges. So that is why magnetic length always less than the geometrical length. Relation between the magnetic length and geometrical length is most important formula. Examiners focusing on this. Magnetic length 2L is equal to 5 by 6 into geometrical length. Next one, magnetic moment. It is the magnet. Magnet has the two poles, north pole and south pole, and another one is midpoint. We know. Here, distance from north to midpoint L, from midpoint to south L, north to south is equal to 2L. So 2L is the length in between the north pole and south pole. This length is called magnetic length. The ability of attraction of the pole of a magnet, that is called as pole strength. Pole strength. Now, the product of pole strength and magnetic length is called as magnetic moment. So, magnetic moment is defined as the product of magnetic length and pole strength. Magnetic moment defined as the product of magnetic length and pole strength. What are the units? SI unit, ampere meter square. What is the SI unit for magnetic moment? Ampere meter square. Important one. This is also. Next one, axial line. It is the north pole. This is south pole. It is midpoint. Now, draw a line from north, south and midpoint. A line which is drawn north, south and midpoint, and it is parallel to the horizontal surface, that is called as axial line. The line which joins the north pole and south pole parallel to the horizontal surface is called as axial line. Now, if the magnet is bisecting along this axial line, what happens here? Yes, it's split into two portions. One is upper portion and another one is lower portion. Two portions formed. Here, what happens? See, magnetic length. What happens? The magnetic length. Magnetic length. Magnetic length is 2L. 2L dash is equal to length remains same. Here it is, let us suppose this is a material. If it is bisecting like this, what happens its length? No change its length. No change its length in its length. So that is why magnetic length is remains same. 2L dash is nothing but 2L. Next one, magnetic moment. Magnetic pole strength. Pole strength. Pole strength M dash is equal to, it should be half of the initial value. Why? Because here actual pole strength is this one, but when it is bisecting, what happens? It cut into two pieces, that is M dash is equal to M by 2. Therefore, what happens? Its magnetic moment. Magnetic moment is how much? Magnetic moment M dash is equal to how much? How to solve this? Let us see. Magnetic moment M dash is equal to 2L dash into M dash. What is 2L dash? Yes, we know 2L dash is remains same. So it can has been like 2 same, that is 2L. What is M dash? M dash is M by 2. M dash is M by 2. Why? Because pole strength is half of its initial value. Therefore, M dash is equal to, don't get any cancellation, right? So it can has been like to 1 by 2 into 2L into small m, which is equal to 1 by 2 into m. This is the magnetic moment. So therefore, magnetic moment M dash is equal to half of its initial magnetic moment. So what is the conclusion here? See, if the bar magnet is bisected along the axial line, bar magnet bisected along the axial line, magnetic length no change in the magnetic length, but pole strength is half of its initial value. That is why magnetic moment also half of the initial value. This is next one. Equatorial line. What is equatorial line? It is the magnet. Every magnet has two poles. Now only we discuss. That is north pole and another one is south pole. This is the midpoint. Right. North to midpoint is L. From midpoint to south also L. Okay, this is the magnet. Now, if we bisecting along the equatorial line, this bar magnet is bisecting along the equatorial line. What happens? It split into two parts. One is this one. It is the one magnet. This is the another magnet. What happens here? Let us see. Magnetic length. Magnetic length 2L dash is equal to, magnetic length 2L dash is equal to half of the initial value. Next one, pole strength. Pole strength will be remains same. Pole strength will be remain same. Why? Because its size is remains same. No change in the size. No change in the size. That is why it remains same. Right now, what happens? The magnetic moment. What happens? What happens? Its magnetic moment. Its magnetic moment M dash is equal to 2L dash into M dash. Here see 2L dash is equal to 2L by 2. M dash written has been like to same. Why? Because no change in the pole strength. Therefore, 1 by 2 into 2L into small m, which is equal to 1 by 2 into capital M. Therefore, M dash is equal to half of the initial value. Like this, we can calculate or we can identify the changes. If the how to frame the question here? If the bar magnet bisecting along the equatorial line, which of the following remains the same? Yes, which one is remains the same? Pole strength remains the same. Which of the following are change if the bar magnet bisecting along the equatorial line? If a bar magnet bisecting along the equatorial line, which of the following will change? Which can change? Yes, magnetic length, and another one is magnetic moment. In any case, magnetic moment will change. Why? Because it depends on the two factors. One is magnetic length and another one is pole strength. See, and also if the magnet is bisecting along the equatorial line, in this case axial line, in this case also magnetic length is remains same, but pole strength is half of its initial value. That is why moment also half of the initial value. Whatever it is, either the bar magnet bisecting along the axial line or equatorial line, which one will change? Yes, magnetic moment must be change, that is its value will be half of the initial value. This is the equatorial line, and changes are some of information about the magnetic length, pole strength and magnetic moment.